All right, so let's go to 30, 60, 90 triangles. Remember doing this in geometry? There was another type of triangle. We had 30, 60, 90. What was another one? Right, 45, 45, 90. And let's start with that one first, if I can click on that. This kind of looks like a 45, 45, 90, doesn't it? Sure. Let's make it a little bit bigger. Like that. All right, and let's go to a pen. Make it a right angle. All right, so if this side and this side are equal to each other, what do we call that triangle? Do you remember from geometry? It's isosceles. Very good. Okay, it's isosceles. Now, an isosceles right triangle, you know exactly how many degrees this is, because remember, these two, we talked about this yesterday, this angle and this angle right here are what to each other? Congruent. They are congruent. I was actually thinking of something else, but you're absolutely right. They are congruent to each other. What's the word, Brandon? Complementary. Okay, they're complementary angles. Okay, so they add up to 90, and now, Paul, they're what? Congruent. So complementary congruent angles, how much are each of the angles? 45. Okay, so what is it? CPCT. Oh, you remember that? Right.
What does that mean?
Corresponding parts of congruent triangles are congruent. In the book I used to use at my other school, they would say CPCTE. So instead of congruent at the end, they would put equals. You like, is that right? But for years and years, I always said E at the end, so it took me a while when I went to this book to go to the C, but got used to it. All right, here we go, 45, 45. Now we learned something. I'm not going to go through the whole process like I would in geometry to show you why this is all true. I did that last year in geometry. I'm sure everybody remembers all of that, don't they? But I'll just tell you what we ended up with. Okay, so the hypotenuse is equal to, do anybody actually remember? So like if this was x, this would be x as well. There's a relationship between the hypotenuse and one of the, or either of the legs. Square root of 2, very good. You remember that? So it's the square root of 2 times one of the legs. In this case, what are the legs? X. So it's the square root of 2x. Okay? So the hypotenuse is the square root of 2 times one of the legs. So that comes in handy quite often. All right, and let's see how we're going to use this. Let's, all right, so I didn't put anything here for the hypotenuse, so I'm going to put this in there now. So the hypotenuse, if the two sides, the two legs are x, what would the hypotenuse be? Square root of 2x, just like this. All right, now what we're going to do is how does this relate to our trig functions? Well, we're going to go through and list all our trig functions. And these are ones, probably this chapter, you may not need to memorize these, but these are ones that you probably want to memorize. It's not that hard. You'll see them over and over and over again, especially the next chapter that we do. You'll see these quite a bit. So this is the first time that you've seen this. You may not memorize them the first few days, but after you work with them quite a while, you will have these memorized. So what do you want to do first? You want to do the sine? Since we go SOHCAHTOA, let's go the sine of 45. Now watch, these are special triangles, right? 45, 45, 90, and then eventually we're going to do the 30, 60, 90. These are special ones. You can't do this for every single angle. These are just certain angles that, and they show up a lot. I mean, 45 degrees. When people build stuff, you see a lot of 45-degree angles. You also see a lot of 30 and 60-degree angles as well as 90. Obviously, 90-degree angles everywhere. So these numbers actually do show up a lot in real life, I guess, if you want to call it. So the sine of 45 degrees. Now, what's our trig function? It's what over what? Opposite, which is x over hypotenuse. So let's do that. So it's opposite. Now remember, this is just a general triangle, right? I don't know what the length of this is. It could be anything. It could be 2, 7, it could be 158 for all I care. All right, but the sine of 45, no matter how big the triangle, is still always going to be the same. Would you agree? I mean, you put sine of 45 in your calculator, it's not asking how big is the size of your triangle, right? 45 degrees is 45 degrees. And the sine, the relationship between the opposite side and the hypotenuse will always be the same. Does that make sense? So the sine of 45 is what? Opposite over, again, hypotenuse, which is square root of 2x. Now, what happens? Let's simplify this and see what we get. Of course, obviously, the x's cancel, so that leaves you 1 on top. 1 over square root of 2. Can you just do this in your head without doing that whole process? Very good. Square root of 2 over 2. All right, now that's, oops, I missed it. You get the idea. That right there is one of those numbers that is just going to stick with you, okay, especially when you go to pre-calc. This is one of probably There's a lot of important things that you learned in algebra that you're going to use in pre-calc, but this is probably one that I would put number 1 on the list, is knowing these things right here, knowing these trig functions and knowing that the sine of 45 is the square root of 2 over 2. Now, remember what I said yesterday? Right now, in Algebra 2, we're using degrees, but in pre-calc, they start that transition from degrees into what? What was the other word? Into radians, okay? And we will talk about radians later on, just not right in this lesson, all right? But in Algebra 2, we can probably stick with degrees. We're going to be doing a little of both, degrees and radians. All right, let's do the cosine of 45. Let's go a little faster. So this is what? Adjacent over hypotenuse, which is going to be the same exact thing, isn't it? I'll just write it out. And cancels, cancels. 1 on top. Square root of 2 over 2. There we go. It's a better circle. Let's do the tangent. So square root of 2 over 2. Do you think that's something that you can memorize? We're not memorizing the decimal approximations, are we? We're memorizing the exact value for this thing. So on your calculator, you're not going to see square root of 2 over 2. You're going to see a decimal number for this. I think it's like 0.707 or something. Somebody do that real quick. Put sine of 45 or cosine of 45 in the calculator. Haley, what'd you get? Yeah, look at that. See, I do remember. All right, so the tangent of 45. Let's do this. Here's 45 degrees. The tangent is opposite over adjacent. Well, you see what that is right away, don't you? That's an easy one. It's 1. Somebody punch that in your calculator. Tangent of 45. See if I'm lying or not. What'd you get? Malik? Tangent 45? 1. Very good. Okay, so you believe me, don't you? All right. So that's kind of cool. I mean, that's those right there. Square root of 2 over 2 is something that you need to memorize. So if I'm walking down the hall and I tap you on the shoulder and say, quick, quick, tell me what the cosine of 45 is, what are you going to tell me? Square root of 2 over 2. And I say, oh, no, I was kidding. What's tangent of 45? What is it? It's 1. All right. All right, I'm being a little silly now, but you get the idea. All right, let's get rid of these. 7 minutes. You think I can do the next thing in 3? No? All right, let's stop it then. All right, we'll go to the next video.